Okay, so we did the lab on biopolymers. So the first image you're looking at the very top is an empty fish or empty food for the cat, and there's no fish in there, and the cat are spread out, and there's only 4. And as you progress down, there's a couple fish in the cat bowl, and so it shows the cats coming together, like forming pairs, sharing the fish, and they. If I can see. They whisper, meow, and then the third image. There's a lot more fish in the food bowl, and as you can see, there's a lot more cats forming, ties together. Like there's a lot more on the top, and there's also different cats on the bottom. There's black coat, stripes, polka dots, and they're screaming meow versus the top. And the last one, you can see thunderstorms breaking up the cats, and so they go in different directions and lose the pattern that they were in.
All right, so the biopolymer experiment was where we used calcium ions of different concentrations to bind together the iota carrageenan, and so those monomers were held together by the calcium ions. And what we found was that the larger the concentration of the calcium ions, the stronger the gel was. And in addition, we also used a protease to break down a glycerin gel, and that broke it down into a liquid. So in this comic, these cats have no food, and the food represents the calcium ions, and that's why the cats are not together. Then in the next panel, they get some food, so these weak interactions are formed between these cats, which represent the monomers. But as you go to the third panel, you realize that more food creates a longer chain and likely stronger, as depicted by the little lines that show the strength. Then another major concept that we learned about was that different types of monomers can come together and form a polymer as well. It doesn't have to be exactly the same. So these cats represent when it's exactly the same, and these cats represent the different types of monomers. Also, the loudness of the meow represents how strong the bond is. So the cats have more energy, and as a result, are louder. Then another concept was that that heat and cooling can separate certain polymers. So here, the cold from the thunderstorm will separate these cats. Yeah.
This artist kind of included really a lot of good concepts in their art. So first of all, the cats and the fish was really good to represent the iota carrageen and the calcium bonding together, because, cats like food, so kind of that the more food they have, the more closer they're going to be. They did a good job of showing that. And also with the meows, like a smaller meow is a weaker meow, so it's kind of showing like a weaker bond between that. It works. And a bigger meow, it's like it's a stronger, connection. They're kind of united. And in the last one, I think it's kind of the other way around. So like one of the things they didn't really clarify, and like they didn't really show in this one, was that the heating actually separates the biopolymers, and the cooling actually keeps them together. So yeah, that was just one thing that they didn't show, but it was kind of hard to depict in this one. Also, maybe scaffolding, like they could show it, maybe the cats in a circle instead of a straight line, or like making a pyramid. I don't know if that would work. Yeah, but overall, it was pretty well done, in my opinion. What?
The types of food.
Oh, that's like art or something. I don't want to like diss them on that.
Yeah. All right,
yeah, thank you.
Okay, questions? All right, I will start with the question. Oh, there's one? Where's the question? Okay, go for it.
So I was thinking, since also in the experiment we used the protease to break down the enzyme, that potentially be what the thunderstorm represents rather than...
Yeah.
Yeah, so it's a bit unclear as to which one the artist wanted to represent, because it could suggest the degradation from the protease. But we're assuming that because this molecule is the iota carrageenan, which did not break down from the protease, they meant to show the cooling instead.
So it is legitimate to sort of mix concepts in a cartoon because it's a simplified version. What is distinctive about cats as animals in terms of their likes and dislikes? I don't know if any of you guys have cats.
Nope.
No cats? No cats in your group. Okay, anybody who has a cat, what do cats really hate? Water. They really don't like water.
Oh.
So, given that, it's still a little, you have to sort of grasp at it. How might that change the interpretation of the bottom panel?
So like it probably like in that context means that the water is driving them apart. So like so like in the real experiment, the protease was the thing that drove the bonds apart.
Yeah, I'm guessing that it is more representing the protease than thermal, just because of the specific negative interaction between cats and water. Okay, so my question is, you talked about it, which is mechanical properties, as something that was sort of the key thing that changed when you changed the amount of linkers. So any idea how you could add that to this cartoon, other than by the size of a meow, in terms of actually representing the mechanical strength of a network?
Maybe like the more food you eat, the bigger you are, or like the stronger you are. I don't know. Does that work?
That could work. Other ideas? Brainstorming. There's no right answer here.
There could also be a different structure from the number of calcium bonds, or yeah. Like that.
Although actually it is the same structure, it's just more connections.
Mm-hmm.
There could be something trying to push them or trying to take something away, something that sort of indicates mechanical strength. Okay, other questions from the audience? We need one parent question. I'm a parent. I've been stuck in this situation too. I wouldn't do anything to you I wouldn't do to myself. Okay, Rita's going to ask one question. You guys get one chance to think. Oh, you have your own.
Sound good. Okay, so I don't know if you mentioned this when you guys were talking. I might have missed it, but I noticed that in the third panel, there's 2 rows of cats, and one row of cat is all the same colors, and the other row of cats are not the same color. So what is that pointing out?
Yeah, one thing we forgot to mention was that for the additional concepts, it says biopolymers can be, when we were assigned homework, we had to include additional concepts. So one thing that we didn't say that was that the biopolymers form exact repeats or repeats of a certain type of monomer. So that's why we thought this person was trying to show that also with the different, like one's dark, one's striped, one's polka dot. So that's what we thought this artist was trying to hint at.
So there's a specific type of name for those types of polymers where you have like a certain patterned repeat. Did you guys learn about the name of that type of structure?
Yeah, it's the polypeptides.
In a sort of more general context, though, do you know what that is called?
The polymers?
So it is a polymer, but when you have the patterns of sort of different ones, it's a copolymer, if I recall correctly. So you're getting like an A, B, C, A, B, C, A, B, C. So when it repeats in that kind of regular order, that's a specific type of polymer where it's not the same monomer, but it's different monomers that can form a repeating pattern.
Other questions? Parents, this is your chance. Everything you want to know about biopolymers. Okay, what is the most common biopolymer that everybody in this room has interacted with? Or sorry, the most common biopolymer gel that everyone in this room has interacted with?
Gelatin.
Trade name?
Jello.
Jello. This was a lab on basically Jello. Okay, I don't know if parents are going to really get to go to the reception, but we got a few more talks to work on it. Okay, can the artist stand up? Hey. Hey.